Number 19. They're wanting you to tell what the transformations were, and then from those words, write the equation. Okay, well, to be able to know what transformations have occurred, you kind of have to know what a standard square root function looks like. Remember, a square root function, the parent function of it is y equals the square root of x. Its starting point is at 0, 0, and its slope is 1, so it'll go up 1 over 1, and then it looks like that. So how is this one that's been graphed on your paper different from the parent function of a square root? It's reflected over the y-axis. Good. And what else? How else is it different? It's a little bit steeper, right? This one, they both start at 0, 0. That's where both of their starting points are. But for your parent function, to get to the next point, you just have to rise 1 and run 1. Well, to get to this next point, don't you have to rise 2 and run 1? So that means it has a slope of 2. Now, those are the only transformations that have occurred. To write that as an equation, you write y equals, it's a square root function, it has a slope of 2, the slope always goes out front, and then x, it didn't move left or right, so you don't add or subtract anything to that. It didn't move up or down, so you don't add or subtract anything at the end. But how do you represent a reflection over the y? A negative on the outside or the inside? Inside. Now, you have a graphing calculator. So once you have written your equation, couldn't you easily type in what you think it is and make sure it matches the picture you've been given on your paper?
Yeah.
And it does. And look, we can even go as far as, pay attention, we can even go as far as going to the table and looking at some points. Why does it say error for all of these y values when the x values are positive? None of that black curve was graphed on the positive x-axis, correct? Everything was on the negative side, so we need to go to the negatives. Okay, we have a point at 0, 0. Then our next nice point is negative 1, 2. And then there's another point at, I'm looking for another whole number point. There might not be one. Negative 4, 4, look. 1, 2, 3, 4. 1, 2, 3, 4. Doesn't that go right through that point? So that's another way of knowing you've got the right equation. It matches up with the table's points that you have right here. Now the next one. Number 20. Keep in mind, anytime you're trying to figure out the transformations, to know how it's been transformed, you have to know what the parent function looks like. The parent function starts at 0, 0, and then to get to its first point, you go up 1 over 1, and it always goes to the right. That's what the parent function of a square root looks like. So how is this one different? I don't see a reflection. Isn't it still starting and going to the right, just like that one started and went to the right? Right and up. So there's been no reflection. It's still going right and up, just like it normally would. So, but what has happened to the starting point? Left 2. And down, what's that, 4? Oh, that's only 3. Okay, now let's look at the slope to make sure the slope is the same. To get from this starting point to the next point on it, isn't it still up 1 over 1? So the slope is still 1. So to write this equation, it'll be y equals slope of 1, which you could write right here, but you don't have to. It's understood. And then the square root. To represent left 2, you'll put x plus 2 on the inside. And to represent down 3, you put minus 3 on the outside. And then we won't do it for every problem, but once you've written your equation, I would always suggest graphing your equation and making sure it looks just like the one on the picture they gave you. And then you'll know if you did it right. Okay, why don't you take a second and try 21 by yourself before I just go over it for you. Okay, number 23. Where'd I get what from? horizontal shifts are represented on the inside of the root, and they're always opposite of what you would think. Right 2 is actually x minus 2. Left 2 would have been x plus 2. Vertical shifts, like up and down, are represented on the outside. Up 2 is plus 2, down 2 would be minus 2. Okay, so let's look at this one. When you're trying to figure out your transformations, you have to kind of be able to visualize what the parent function of a cube root would look like. Remember, a parent function of a cube root would start at 0, 0, go up 1 over 1, and it would go down 1, back 1. So it would look like this. Okay, that's what the parent function would look like. So how is this one in black different? It has been reflected. And for cube roots, it doesn't matter over y or over x. You'll just put a negative on the outside. Okay? And what else? Besides reflected, what else? The center was at 0, 0. Now the center is at 2, 0, so correct. It's been moved right 2. So to write that as the equation, you do y equals, it's a cube root. To represent right 2, it's x minus 2. It doesn't move up or down. So, I mean, technically you could write plus 0 out here, but that's not necessary. And to reflect it, you throw a negative out front. With cube roots, if there's a reflection, always put the negative on the outside every time. Okay, why don't you take a second and try 24. Alright, number 24. Okay, the center, I'm not going to keep drawing the parent function every time because you should start just kind of knowing what's happened. The center has moved from 0, 0 to here, which is what kind of shift? Right 2. Has there been a reflection of any kind? No, it's still going up and right and down and left like the parent function does. But what else is different about this one? The slope. It's a little bit steeper. To get from your center point to your next point, instead of going up 1 over 1, you go up 2 over 1. Or in this case, down 2 over 1. So the slope is 2. So we go right 2 and a slope of 2. So y equals the cube root. To represent right 2, it's x minus 2 and a slope of 2. The slope always goes in the front, so a big 2 out in the front. Okay, go ahead and try 25. If you've already done it, go ahead and try 26 and 27. Alright. What has happened with this one? How has the center shifted? Up 1. Is that the only thing that's happened? It also reflected. Is the slope still 1 like a parent function of it? Yeah, it's still got a slope of 1. So we don't have to worry about putting a number out front. Well, the only thing we have to worry about putting out front is a negative to represent the reflection, and then a cube root because that's a cube root function. Nothing goes on the inside because it didn't shift left or right, but it went up 1, so plus 1 on the outside. Okay, if you haven't already tried 26 and 27, go ahead and try them before I go. Alright, for number 26, I noticed that the center has moved down here, which is a shift of left 3 and down 3. Okay. Left 3 and down 3. Okay, the center is now at -3, -3, which is left 3, down 3. When I look at it, I see that it has a slope of 1, because to get from the center point to the next point, you have to rise 1 and run 1, either way you go. So slope is 1, so that's not going to matter in our equation. And then there's been no reflection, because just like a parent function, it's still going up and right and down and left. So those are the only two transformations. So that would be represented with the cube root of x plus 3 and then minus 3. Is that what you got? Okay, number 27. The first thing I notice is that the center is still at 0, 0. So there's been no horizontal or vertical shifts. So what that means about the equation is there's going to be nothing inside with the x, and there's going to be nothing outside over here, because it hasn't shifted right, left, up, or down. The center's still at 0, 0. The only thing I see about it is that now to get from one point to the next, you have to go up 3 over 1 or down 3 over 1, which is a slope of 3. So that big 3 goes out front. That's the slope. I also notice that there's been a reflection, because with a normal cube root, a parent function of it, it opens right and up and down and left. Well, this one's doing the opposite, which means you need to put a negative out front to show that reflection. Did anybody get that one right? Okay, turn to the next page. Okay, now we're going to do them without a graph. They're going to give you the words, and you write the equation from the words. Write the equation of the square root function that has been translated right 10 and up 6. So y equals, it's a square root, so it's going to be x, right 10 would be minus 10, and then up 6 is plus 6 on the outside, and you're done. Now, just like always, even though we don't have a picture, think about it. You could go to y equals, graph your equation, and then make sure it matches the description in words. Okay, and you can barely, see how it's right over there, the starting point, you can barely see it? Well, isn't that because it went right 10, which is way over here, and then up 6? So that's another way you know you've done it right. Number 30 says, write the equation of the cube root function that has been translated 4 units left and reflected across the x-axis. So y equals, it's a cube root, so you have to do that. Left 4 would be x plus 4, and then reflected for cube roots, the negatives can always go outside. You don't even have to think about where the negative goes for a cube root. If there's a reflection, it goes outside. If they don't specify that there's been a change in the slope, then you just assume it's 1. And so that's the understood 1 out here. Yeah, it'll tell you, or you'll see in a problem coming up. You'll see. All right, number 31. Write the equation of the square root function that has been translated left 2 and reflected in the y-axis. So this time it's a square root function, so square root of x. Left 2 would be plus 2. But to reflect across the y-axis, it does matter where the negative goes because it's a square root in the inside. Now, since you have more than one thing on the inside, you have to put it all in parentheses before putting the negative. If you don't, it'll be messed up, and when you graph it, you'll see that it does not match the description. Okay, so anytime the negative goes on the inside, you need to put whatever's in there in parentheses. But you'll only need a negative on the inside when you're doing a square root that's been reflected over the y. Any other time, the negative will go on the outside. Okay, number 32. Write the equation of the square root function that passes through the points 0, 0, and 1, 7. Okay, for this one, when I was working them out myself, I thought, well, drawing a little sketch could be helpful. Because if I have a point at 0, 0, which is the origin, and then right 1, up 7, want the function look like this? And now that you have like a little sketch, even though it's not great, it makes it easier to write the equation. We know it's square root, so it's going to be like that. Did it say it was shifted left or right? No, so it's just going to be x, nothing added to it or subtracted, nothing on the outside added or subtracted. But, think about it. If the first point, the starting point's here, and your next point is here, that's the slope of what? So you put a big 7 on the outside. So that's one way they can show you a different slope by giving you 2 points and you figuring out what the rise of a run is from the points. Okay, number 33. This is another one where drawing a little sketch can be helpful. Write the equation of the square root function that has a domain of x is less than or equal to negative 1 and a range of y is greater than or equal to 2. Well, what does x less than or equal to negative 1 mean? And goes which way? Okay, look. Here's negative 1 on the x-axis and then positive 2 on the y-axis. Well, both of them have an equal to. So that means there's a point that's exactly at negative 1, 2. But then it lets you know everything else is less than negative 1, which would be this way, and greater than 2, which would be above. So you have to be left of negative 1, but above 2. Well, wouldn't that look like this? So now that you have a little sketch, it's easier for us to write the equation. Y equals, it's a square root function, to get to that starting point, don't you have to go left 1, which would be x plus 1, and you have to go up 2, which would be plus 2, and remember, normally our square root functions go up and right. This one is going up and left, which is a reflection across the y-axis, and reflections across the y-axis, the negative has to go inside, which means you put everything in parentheses. Okay, I'm going to give y'all a couple of minutes to try the right side by yourself, and then I'll go over them. Okay, but you need to try them. They're pretty much just like the ones on the left side. So look back if you need to. Be quiet. All right, y equals the cube root of x plus 3 minus 5. That's what you should have got for 34. That's a shift of left 3. That's a shift of down 5. And then there was no reflections. The slope was normal because it didn't say anything about the slope being different. So that's the equation. Number 35, y equals negative square root of x plus 8. Because the only two things they told you it did was up 8, which is plus 8, and reflected on the x, which means the negative goes on the outside. If you're ever unsure where the negative goes, graph both of them in the calculator and see which one flips over the x. All right, number 36. Y equals, okay, look, this one is a square root, but this time the reflection is on the y-axis, so the negative goes on the inside. And then it moves down 9, so minus 9. Okay, number 37, it gives you 2 points, 0, 0, and then 1, negative 3. So right here. So that means there's not only been a reflection across the x-axis, which is represented with a negative on the outside, it didn't shift left or right, but it has a slope of 3. So y equals negative 3 square root of x. Okay, then the last one. You know you have a point at exactly 3, 4. So 1, 2, 3, 1, 2, 3, 4. And then it says everything has to be greater than 3, which would be to the right of 3, but less than 4, which would be below 4, which would put it that way, correct? Right of 3, but less than 4. So that equation has been reflected across the x, because normally it goes this way. Well, now it's going this way, which is a horizontal flip. A reflection across the x-axis is a negative on the outside. It moved right 3, which is represented with an x minus 3, and it moved up 4, which is a plus 4 on the outside. Anybody get that one? Okay, tomorrow we have a quiz. There will be videos posted from today and Friday. I'll send you the link to your Remind tonight. You need to study. It's been a while since you've seen some of this.
Yep.